Okay, good afternoon, ladies and gentlemen of Altitude Honors. Today we're going to go over a review or a preview for Algebra 2 Unit 1 test. And these are the topics that are going to be tested, most of which are somewhat related to the test we had earlier. But we're adding the inequalities to this in absolute value equations, inequalities, right? So let's go ahead, and I appreciate that most of us are here today. We're missing Bryce, and Bryce is an active commenter, so we're going to have to make up for Bryce being gone.
I'll do it.
Yeah, so
What?
1 to 2, we got a 3.
Okay, what is the range of the relation shown in the table? We have a table. What is the range of this? Now again, this preview is taken from that test, and I just took excerpts out of it and changed up some things and concepts, so that's what we're looking at here. Okay, what do you think for this? What is the range of this thing going to look like? 2 to 17. So, like an inequality type form? Is that what you're saying, Ben? Like this? Is that what you mean, Ben? Is that right?
Yeah, I think so.
Wouldn't it be y instead of that?
Okay. Everybody agree with Addie on that? Very good. Let's look at that. Okay, good job, Addie. What else? Anything else? Is this what it is? What do you think? Okay. This is not what it is.
I didn't think so. I really didn't think so. I wasn't feeling right now.
What is it and why? Let's erase it here. What is it and why? And why, let's just do this. Why not this? What makes this thing not correct?
Has an irregular slope.
Yeah, what it is, it's going to be like a scatter plot that won't fit a perfect line. So that's what you're saying, Ben, right? Yeah, but that isn't what makes it wrong. What is this telling you? This is telling you that not only is 2 part of the range, not only is 17 part of the range, not only is 7 part of the range, 10 and 15, what else is part of the range?
Everything in between.
Thank you, Jay. Everything in between, right? But we don't see everything in between. We just see what? These particular numbers. So this work is what we call discrete data. Whereas this thing here is representing continuous. Now, in real life, continuous, anything you measure pretty much is continuous, like time, temperature, something that is weight, that increasing, decreasing, right? But these are specific data points. And so what would the proper representation of this be?
infinity?
Well, infinity, I mean, if you look at the data, you might be able to visualize an extrapolation out toward infinity, but you are not given that, right? This is the only, I mean, these are the only data points you have to work with. And so we have 5 coordinate pairs, that's it. So how are we going to represent the range of this?
Set notation.
That's what I would use. I would use set notation. That would be my, now there's another way we could do it. We can't use inequality notation, right? Because that's, but y equals, now this is the way I would do it. This is what Ben suggested, I think, Ben, right? Is that right? That's a way to do it. There's another way that's a little bit awkward. Now sometimes, since the thing is asked like this, you could actually put it in brackets without putting the y equals. I like putting y equals here myself because that's just more unambiguously specific, right? Now, another way you could write this, you can write this in interval notation. Okay, and that's going to be, interval notation is going to be like this. Yeah, and so what it is, Jay's saying, yeah, this is going to be a little bit, okay? To me, this set notation is a little more efficient, I think. So, anyway, that is that. Okay, next, what is the domain of the relation shown in the table? So go ahead and piece that together. Okay, for this one, does that look right? Mm-hmm. Yeah, that's going to be right there, okay? Next. What are correct representations of the interval shown on the number line? And how many types of representations have we talked about in this class? Okay, Ben is going like this. 3, he says. And those are the main ones. There are a couple others too, so I'm thinking there are 5 total we could have for this, but there are 3 main ones that we've talked about right from the beginning of the school year. What do you think, Bryce?
You see, I haven't quite got the answer yet, but I don't know. And I'm just focused on my steers.
The Bryce invitation.
It's pretty spot on though.
What do you think? Over here. What do you think over here this way? What do you think should be a representation of this?
would you, would it be like in that order? Would it be -3?
Negative infinity?
Would it be less or?
Let's understand what's happening here, okay? What we're seeing is, we're seeing a point here at -3. We're seeing like an open interval circle here
So would it be
at 4, and then in between those two endpoints.
No, it's less than.
Or less than X.
Yeah, so J is kind of quietly here, but he's saying -3 is less than or equal to X, which is less than 4. Is that right, Jay?
Yeah.
I thought it was closed whenever the bracket, I thought it was open, the bracket was open whenever it's equal to.
That might be right, but I get those confused.
Okay, so this is inequality notation. And is this right?
Yes.
So that's inequality notation. Okay, good. That's one of the 5. What else do we have?
So,
We have set notation. Okay, let's do set notation. We have X such that, and we can just plunk this right down there like this, right? Okay, this is called set, or sometimes it's called set builder, but that's what that notation is. Okay, what else? Interval notation. What does interval notation look like here? Yeah, something common something. I'll put-
-3, -4.
So-
maybe brackets then, in front of the -3?
So bracket here.
and a parenthesis for the 4.
bracket here. So this is called interval notation. Okay, and I mentioned that there are yet 2 other kinds of notation. What other kinds of notation are there? Representations. Okay. One is called a verbal. Okay, verbal is going to be X is greater than or equal to -3 and less than what? 4. So that'd be a verbal notation. Okay, and there's one more. What is the other one? What do you say? Yeah, okay, and Gabby says finite interval, and this is, by the definition, this is a finite interval right here, right? Because it doesn't have infinity as part of the deal. That's the type of interval. I'm talking about types of representation. Okay, this one, the last one we're going to look at here is a 2D coordinate plane representation. So what you have is you have X is equal to 4, and you have X is equal to -3, and then what happens in between these two? Shading. You ever seen that notation before?
Yeah.
Yeah. So 5 types of notation or representations. Okay? And these ones here are the ones we've been primarily focusing on since the beginning of the year, right? Okay. And I think on your test, you're going to be asked to do one of these 3 here, I think. Okay, next. We have a situation here. Jacob earns $20 each week for his allowance plus $30 for each week of police services. He wants to earn at least $150 each week, write an inequality to represent the situation. Just look at your shirt. And by the way, Jay, we didn't have a chance to do music yesterday, so maybe we'll have some time today, I don't know. Yes? What do you think?
Did you combine the 40 and the 20?
Okay, so Marcus is asking if we would combine the 30 and the 20. Would we?
No.
Why not?
Because one's like a, well, one's like, you get it every time you do a swimming pool, and the other one you get this once a week. Just like a one-time thing.
Okay, I don't,
I've heard it's fine.
yeah, and Connor is kind of recessed into obscurity at the back of the classroom. So I'm going to try to recreate his explanation. He says, and correct me if I'm wrong, Connor, you say that during a week, this swimming pool thing is going to perhaps happen multiple unknown numbers of times, whereas this thing here is just once, right? So this is going to be one time, and this one here is going to be many times, possibly, or none, right? But he's gonna get this, no matter what. So, and to me, this is a little bit confusing because you notice we have the word each in both of those expressions there. So it is kind of confusing. So you have to kind of look at it and think through. But I think Connor's on target here. So what is going to be our inequality for this?
20.
So 20x, you say?
Plus 30y is greater than or equal to 150.
Okay, well, what do you think about that?
It wouldn't be 30Y, would it? Because it's not like constant, right?
It wouldn't be 30y, so you're saying J would be like 20x plus 30?
I don't know if that's
Is that what you're saying, Jay?
Wait, or would it be the opposite because 20, because he says he wants to get $150 each week.
Oh, yeah.
So would it be the 20 that doesn't?
So you're thinking 20 plus 30x?
Yeah.
Is that what you're saying?
Yes.
And that's going to be greater than or equal to 150? Yeah, and I think this is going to be your correct representation right here, okay? And this one here, this y, well, we know that's going to be each week here, right? But this is going to be constant here. So we know we're not going to have that, so those are pretty much the same thing, right? So this will be our this will be how we would do that, okay? Okay, good job thinking through this. Okay, next we have this one here, find the inverse, and I'm going to go ahead and put inverse function. The inverse function of fx equals 5x minus 3. Find that. All right, did somebody come up with an answer on this yet?
I did, but I don't think it's right.
Okay, Jay, let's go ahead and see what you have anyway, because Jay, is that kind of, is that,
1/5 x plus 3/5.
so this is what Jay got for that, is that right, Jay?
Yeah, so
Okay, anybody else? Anybody else second that work? Is that what you got too? I'll make sure. You got that too? Let me make sure I got this here. I'll make sure I get this in my view screen. Okay, that looks a little better. I'll make sure this is in our view screen. Okay. All right. Ben, you got that too? Anybody else? You got Sam?
what are your questions?
Yeah, I got it right there.
You got that? Riley, you get this too?
Jay, did you get it?
Yeah, I got it.
Okay, let's just go for the record, and everybody got it except for those who didn't admit anything, but for the thoroughness of our remote learners and everybody else, right? We're gonna go ahead and put,
Show them how you did it.
yeah, we're gonna show how I did it, so, and Jay, I want you to help me with this, Jay, that was good work. So we get y is equal to 5x minus 3. So is that what your first step is, Jay?
Yeah, and I switched the x and y.
So we have x equals 5y minus 3,
And I added 3.
add 3. So you get 5y is equal to x plus 3,
And I divided by 5.
5. So you get y equals 1/5 x plus 3/5, is that right? And then we have our last step down here. Any comments on these? Okay, what do you notice about this first representation versus the final answer?
It was flopped over.
Flopped over, kind of, that's a way to put it, yeah. Yeah, so that's so Connor says flopped over, kind of.
Exactly.
Looks like it might have wiggled a little bit too long.
Maybe. I can't tell you.
Yeah, so what do you notice about the slopes of the original and the inverse?
It's a reciprocal.
So they are reciprocals of each other, right? They're reciprocal pairs. And another thing that happens too, probably most of the time, you'll notice that you'll have minus something here will turn into a plus something over here. Now I can't guarantee that it happens that way 100% of the time for reasons I don't have time to explain right now, but that's what you'll notice a lot too. Another thing you'll notice too is that possibly, could you write this in decimal form? Yeah, you could. So this could show up as 0.2x plus 0.6. So you could possibly see it like that. But I had a good comment in 7th period. Steve-O was saying that he asked the question, could you just leave it in this form here? You really could, right? But why would you go ahead and take the trouble to put it back here in this form? Yeah, so Ben is saying easier to find the slope and y-intercept, and Ben is exactly right. In addition to that, that's the original form. So when we go ahead and turn it back into similarly slope-intercept form, that gives us an easier basis of comparison between the two. So yeah, some real good comments there, some real good work. Let's go on to the next one here. We refer to the graph below for the next two problems. What is the domain and range of the function in interval notation here? What do we have here for domain?
Negative
Negative
infinity,
infinity or positive?
I heard a few of you saying at the time, Jay, Jaden, and range is going to be same thing. Okay, and then it so happens that algebraic functions, the ones that are termed algebraically, tend to have those domains certainly, and often the range too of all real numbers. Okay, next, same graph, but now asking for end behavior of these functions, of this function.
As x approaches negative infinity, and x approaches negative infinity.
So as x approaches negative infinity, f of x approaches negative infinity, you're saying? Okay, this is what Jay is saying. Is Jay right about this?
Yeah.
Yeah. Okay, and someone else we have as x approaches infinity, f of x approaches infinity. So what we have is, I don't know if we got into this yet, but is this function here an odd function? According to the way we define it, no, it's not. But this one here has odd behavior. It's an odd behavior function because the polynomial function, an odd nature function, is going to start low and end high, or start high and end low, right? And then an even nature function is going to start high and end high, like a touchdown. I hope you guys get a lot of football games. Or start low and end low, right? So anyway, but this gets into cheerleading this time. We have a cheerleader right here, about the cheerleader right here. Yes.
Oh, no, you were talking about me.
Yeah,
Oh,
that's cheerleader.
I was talking about this one here that gets thrown into the air. How high do you get thrown into the air? Have they caught you every time? No, they haven't caught you every time. Did you get hurt? Okay, all right. So when it goes like this, odd, odd, even, odd, odd, even. So
Like the seesaw.
yeah, kind of like the seesaw, right? Now the seesaw. But what we try to do is we try to get the cheerleaders to do that. Okay, and we're going to be talking to one of our cheerleader captains in pre-calculus, Katie. She's going to help us out, Abigail. Okay, she's the other captain, right? I think we talked about that a little last year. So anyway, that's something that you have, I hope, something to look forward to. You seem like you're pretty excited about that. She's nodding her head. Sure. If you say so, she says. Okay, good work. Okay, next. Determine whether the following pairs of functions are inverses. And I think on your test you can have 4 examples, and I only put down 2 of them. And you're going to be able to choose, yes, they are inverses, or no, they are not. So this first pair of functions, are these inverses of each other?
Yes.
Yes.
Yes, thank you, Bryce. Bryce, how did you figure that out, Bryce?
You see, like whenever you do the form X, and then you put it over the 1, or under the 1, it's an inverse.
Okay, it's a reciprocal. And what happens is you have to have more than just the slopes being the same. You also have to have like the same, in this case, there's no other term, so you're gonna have, you have 4x like this, is that right, Bryce?
Yeah.
And you're gonna have to have one, you have 1/4 x, which is gonna look something like this. And then these are gonna reflect about the line. What line is this? Y equals x. And you see that the slopes are what of each other? Reciprocals, okay? Thank you, Bryce. Now, what about this one here, the second one? Is that gonna be,
I put no.
okay,
I put no too.
put no, yeah. This one here,
What do you put, Bryce?
Guys, I wasn't sure about that one. So I
okay.
just waited.
It's in your early computer, watch this.
So we have 2 minus 5x, right?
So you're like, wait, I wasn't there.
And we have 5x minus 2 is going to look something like this. And if you look at them, they kind of look like inverses a little bit, right? But these things are reflected about the line x-axis, yeah. So just be careful about that, be deliberate, and you shouldn't have much
I
trouble.
mean, you can kind of tell that they weren't inverses, they're just flipped.
Yeah, because they're flipped, they have to be flipped, but in this manner.
And if it was an inverse, then it would be 1/5 x, right?
Yeah, okay, and Jay is making the comment, if this was truly an inverse, this would end up being negative 1/5 x, right?
And then
Or-
4 or 5.
Or this would be negative 1/5 x, or this would be 1/5 x. Yeah, you're not going to get different signs for inverses. That's a giveaway. You got to have the same sign. Yeah. And you guys who go into calculus, that's when we talk more about that. All right. Refer to the graph below for the next 2 problems. Identify intervals where the graph is increasing. So where is the graph increasing? We'll have f of x is increasing on where?
4 to
X equals, oh, I guess.
4 to infinity.
Negative infinity to negative 2, and where else? You said, and where else?
4 to infinity.
I'm looking at 2 to
Oh, yeah.
2 to infinity.
Yeah.
infinity. Now, you gotta look at, okay, when it says where the graph is increasing, look over there where Addie is.
I was thinking it didn't count to.
See where Addie's sitting, right there by that eraser, right behind Addie? The where, what crossword there. See that? So where is gonna refer to the x values. And then, so that's gonna be that one, right? Okay. Next one is gonna be identify intervals where the graph is negative. Where do we see the graph negative here?
Negative 2 to positive 2.
-2 to positive 2. Okay, so we say f of x is less than 0 on interval of -2 to positive 2. Is that right? Well, no, it's not, because the thing's positive in here. Now it's negative in here, but it's positive here. So this would not be correct representation. Where is the graph negative? What are we talking about?
Negative infinity to 4.
0 to 4 and negative infinity to 4.
Or negative infinity.
Yeah, so I heard Jay and Jaden say, Jaden says 0 to 4 union, you say negative infinity to -4 is what you say, Jaden?
Yes, sir.
Yeah, that's right. Now, conventionally, what you're going to usually see, you're usually going to see that's kind of switched around, because usually, just by convention, now this is still correct, but by convention, you probably want to put this interval on the left first, okay? So interval -4, union 4, comma infinity. Okay? All right, good work. Let's go to this one here, figure below refers to the transformation of y equals absolute value of x. What is the equation represented in the graph? Y equals what?
-2. No. No. No.
What equals? You know what I'm saying?
Okay, absolute value.
Yeah. X.
Yeah, plus
And then
+1.
plus 1. Okay? Everybody get that pretty well? And you'll be able to test these using your notes and calculator, right? Just like, look like Marcus has that calculator all ready to test this. He'll be taking that test and he'll say, oh man, that was an easy
When
one.
is this test?
Probably Monday. And we'll probably be done with the review in time for Friday, but I'd rather not take a test on Friday. Okay, what is the range and set notation? So range is going to be what?
one. That's infinity.
Okay, set notation, y such that y is greater than or equal to 1. Alternatively, you could write that as y such that y is, let me put over here, y such that, you can put -1, or not -1, 1,
Less than negative infinity.
so infinity. So you could see it in either of these methods. I'd rather, to me, this one on the right is a little more economical, is all. But other than that, it's the same thing.
They would both be correct, though.
Okay, and then we have graph the solutions to absolute value of x minus 2 equals 3. How would you do this one?
You would add the 2 to the 3.
No? What we do, we set it up, we set this up. F of x equals absolute value of x minus 2, and g of x equals 3. And we would graph these two. So here's our g of x equals 3, right? Okay, that's going to be y equals 3. And what about this one here?
Slope is,
The slope would just be 1.
Slope will be 1, right? Where would be our vertex?
-2.
-2, 0.
So there's 0, -2, right? So then we'd be looking at this thing here, if I could do it right. So something like that, and then like this. It's supposed to go right there, okay? So here we get -5, comma 3, and 5, comma 3, right? So what's going to be our solutions here?
-5 and 5.
-5 and 5. So you can put x equals -5, 5. Sometimes you'll see this also written as x equals plus or minus 5. You can see that written like that too, okay? It doesn't give any types of notation other than that. So I really think that handles I think that's everything we have on our review. You have any questions on that today? Okay, good job. I want to thank everybody.